Hello everyone, I'm Ishmam Zabir. Today I'll be giving you guys some overview about computer vision and some applications of that, and finally uh, I'll be writing a small project about face detection, which is very common in computer vision. Okay, so throughout this workshop, I'll be I'll be discussing about what is computer vision, and then what are the applications in this area, and we'll give you also some few examples to understand that, and finally I'll be discussing about a face detection project. Okay, so what is computer vision? So computer vision is basically uh, to enable your computer to understand what actually we understand, right? I mean, if I gave you an image, you can easily interpret what is in that image and what does it mean. But for computer, it's hard to interpret, right? Because uh, let's say in this image, it is easy to understand that this is an image of a building and there are some objects in front of the building, right? You can easily interpret that. But 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 the computer sees what computer sees is that it sees a matrix. Okay, so it just receives some numbers. So uh, how does it understand that it is a building, or there are some objects in front of that, right? So it's basically some sort of intelligence that the computer needs, right? So building some algorithm and enabling the computer to understand that is basically the areas of computer vision. Okay, so now I'll be talking about few classical methods in computer vision or image processing. Okay, so first we need to talk about image acquisition. Okay, so what is image acquisition, or how do we acquire an image? Okay, um, if I give you any video, you can easily uh, take the frame out of the video, okay, and then process it, and then uh, extract some important information from that image. Okay, so this is basically the image acquisition. Okay, you can do it by your camera, you can do it by some other techniques, or you can do it some other kind of imaging. You can do it by other kind of some other imaging devices. Okay, so this is basically image acquisition. And then sometimes you need to pre-process the image. Okay, because the image that you receive sometimes may have some noise, may have some unwanted data that you don't want. So you should get rid of that unwanted informations from the image, or the redundant informations. So that is called pre-processing. Okay, sometimes we do some filtering operation to get rid of this noise. So there are a lot of actually techniques. So and go through the details about pre-processing of the methods. Then the most important part we need to talk about is feature extraction. Okay, so there are definitely some important features in image. Okay, for example, if I talk about face detection, okay, what are the key feature you observe in face? Well, the important thing is usually faces are symmetric. Okay, if you cut the half of your face, your other half is usually symmetric to the your right side is symmetric to the left side. Okay, so there's some front face image. Okay, so these are some features, and there are some definitely other features that you can extract from the image. And then once you have the features, you can easily come to any decision that it is face or something. Okay, based on the features. So if you want to process an image, or if you want to give some intelligence to the computer, you need to extract some features and make the decision on that. Okay, so And then another topic is image segmentation. By image segmentation, actually, we mean that we segment out the important region from the image. Okay. And then pattern recognition. We need to recognize some patterns in the image, because obviously there are some patterns that repeats itself in the images. Okay. For example, if I gave you 10 image of cat, and if I gave you 10 image of dog, or if I gave you other image of cars, you can easily figure out what are the patterns, right? You can easily understand what are the cats and what are the dogs and what are the cars, right? How? Definitely there are some patterns, okay, that in your subconscious mind you process, okay? So you need to figure out what the patterns, okay, and make your computer to understand the patterns, okay, and make the decision on that, okay. And also same thing that I discussed is image classification. That means to classify what are the image of dogs, what are the image of cats, and what are the image of cars, okay. So to classify the images, okay. Then let's uh, move on to the application part, okay. What are the applications in computer vision? Uh, to be honest, this is the most fastest growing field in research, okay, because computer vision is everywhere, okay. For example, in object or face detection, you need to apply the algorithms from computer vision. For example, Piaget Jones algorithm is still the most popular algorithm in face detection. Also, people also have worked on top of that, okay, and improve the method, but they'll but this is the most, I mean, used algorithm and commonly used, okay. And then next move then the other application is navigation and autonomous car, okay. So autonomous car is the next big thing, as we know, because all of the industries, the car industries, are focused on launching the autonomous car. Whoever first comes with the autonomous car will actually capture the whole market, right? So, so how does the autonomous car works? Okay, when we drive, we can see the objects through our eyes. We can make decisions on that. Okay, but when we have the self-driving car, it definitely needs to have some intelligence. It definitely needs to have some vision. Okay, so so in the autonomous car, basically there are if I'm not wrong, there are probably 4 or 6 cameras mounted on the car on different locations, okay? And they capture images, and based on the images, they basically detect the other cars around it, and they also need to detect the traffic light, right? Because if the traffic light is red, and if you still pass through it, you'll be in trouble, right? So it's still under developing it's still under developing project, okay. There are a lot of issues related to self-driving car, and people are working on that to improve this area, okay. And also same application in navigation, uh, and also in robotics or UAV, I mean the unmanned aerial vehicle. The vision applications are very much common, okay. Because, for example, in UAV like drone or aeroplane, they need to have some uh, they need to have some algorithm to detect the objects, right? To detect the obstacle. For example, if you are flying any drones or any unmanned vehicles, okay, you need to figure out, you need to actually avoid the obstacles, and you also need to detect the what are the images that you need to capture, okay. And then another application is on authentication and security. Currently people are people in recent are more focused on their uh, mobile device or personal device, it's very prone to security attack. Okay, for example, password and some um, finger swipe are not very useful in our phone. People may easily break the security, and sometimes it's not hard to retrieve the password. But to be honest, I mean, there are a lot of important informations that are hidden in the mobile device or computer. Okay, so people currently are focused on some biometric features to increase the security step or increase the application layer security. So here also the computer vision comes. As you know, for in iPhone 10, they tried to launch the face recognition as a security, right? I mean, for the authentication process, they tried to launch the facial recognition. So still there are a lot of bugs because this is still uh, people in researchers in iPhone are still working hard to solve this problem. But in research, this is an open problem. There'll be a problem to deal with. Okay, and then in action recognition and object tracking, this is also important. Uh, for example, if you have a security camera, and what you need to do, you need a lot of people to you need a lot of people to track what are the activities, right? But sometimes, I mean, it's hard to track all the cameras. What if your computer can do the job for you? What if the computer can track the people in the image? Okay, track the humans, and also they can track the anomal activity, right? Or abnormal activity, and they can alert, or they can call some emergency number to deal with that, right? This is also very uh, useful application in our real life. Okay, and finally if I talk about the success in computer vision, that is, in definitely I have to talk about medical imaging. Okay, uh, this is one of the success stories in computer vision. For example, if I talk about uh, MRI imaging, people, in fact, I personally worked on MRI image, okay, where I have the MRI scans of any patient, and they have tumor. So what your computer can do, your computer can figure out the tumor from the image automatically without the help of doctor or any diagnostic or any expert. Okay, so this will definitely help the doctors, and also this will guide proper treatment. Okay, so these are the applications. And give an example of computer vision in my real life. Well, a few months ago, while I was driving through the freeway of California, we accidentally entered in a toll road. Okay, then I didn't see any toll booth. Okay, there. I was thinking, I was wondering how they'll collect the toll, or how do I pay the toll. Okay, because there's no toll booth like in our country. There's no people to collect the fees. Okay, then suddenly I got the answer. Okay, while we were driving through a tunnel, there was a computer. There was a camera. It captured a high speed image. We are definitely in high speed. Okay, like 60 mile per hour, but it took a picture of the car uh, within that speed, and then what it did, it actually read out the name. It read out the license plate. Okay, it segmented the license plate from that whole car. Okay, and then recognizing number plate, it actually sent us the bill. Okay, the machines on computers are doing the task that the people used to do before. Okay, so I was really surprised by that, and this definitely is the outcome of tremendous research effort. Okay, so I'd also like to encourage you to work on this area. Okay, so if you figure out any problem or if you figure out any cool idea to work on, you should definitely pursue. And also I would like to uh, suggest you to uh, go through some topics in machine learning too, because computer vision and machine learning or artificial intelligence are closely related. Okay, because nowadays the research or work in computer vision has moved to the deep learning area. Okay, because people are applying the deep learning algorithm on their image data sets and to um, solve the research problems. Okay, so if you have time, definitely you should read few papers or topics. Okay, uh, I won't be able to talk details about that because there are more advanced problems. Before talking about that, yeah, before going to that topic, I think we have to discuss a lot of topics, okay, or relevant materials to cover that. Okay, so and also I would like to encourage you to um, work on OpenCV toolbox in Python, because this is this is the most, I mean, rich library in computer vision. So the people who work on computer vision usually use the platform as Python because they have a lot of libraries and they have a lot of previously implemented algorithms. Okay, so research. So while you pursue research or while you pursue any project, you should definitely consider Python as your programming language. Okay, thank you. Thank you for listening. Okay, now I'll be going through the code. Okay, this is the Python version of the code. First, you need to install the. You need to first you need to install the OpenCV package, which is CV2, and then import it in the Python environment. Okay, then you also need to import NumPy. Okay, now this is basically a Haar cascade, so which is in OpenCV library, and this is the and this we call the face cascade classifier. Okay, we call it, and then we call another cascade classifier, which is a Haar cascade smile, which will detect our smile. Okay, so we call it smile cascade. Now in this line, we'll capture the video. Okay, so it will capture the video. Now we'll be running an infinity loop. Okay, so where we'll capture the video. Okay, and we'll read every frame from the video. Okay, so this is the image. Okay, then what we need to do is we need to convert this image. Basically this is a colored image. We need to convert the colored image to a grayscale image. So this is basically in the grayscale. Okay, so we'll be using CVT color or the convert color function in OpenCV package. Okay, then in this faces image, okay, where we define the variables. This is the minimum size of the window. So if this is not satisfied, we'll be calling that a face. Okay, so this is the minimum size of the face. Basically this is the pixel 30 by 30. Okay, so we define the window length. So now we'll run a loop, okay, in the face, where we'll draw a rectangle, okay. By calling this CV2 rectangle, we'll draw a rectangle around our face, okay. And this X and W is basically the width and height of the rectangle, okay. And this is basically the color of the window that we select. And then we also segment this. We also segment the face, which we call the RY, or the region of interest, from that image, okay. And then we also take the colored image from that frame, okay, or the colored face portion of the image, okay. Now once we have that, okay, we need to look for the smiley face in between the window of the face, right? Because your smiley face cannot be outside of your face window. It should be inside that, okay. So inside that loop, or inside that window, we'll be looking for the region of smile, okay. So we'll be searching throughout the X and Y axis, okay, the smile. And once we have the smile, we will draw a rectangle, okay. We will draw a rectangle around our face, and then finally, once we have drawn all of that, okay, we will show that in our video frame. We will make a video of that given processed frame, okay. And then we will show. So once we're done with the code, let's compile it, okay. Let's see what happens. Oh, it's detecting my face by this rectangular blue window, but it's accidentally not only detecting my smile, but it's also detecting it's also making some wrong detection with the green window, okay. Now you can run it by your own and see what you can do with that.